Here are solutions for quiz 2 from Math 60. In the first problem, we're asked to find prime factorizations. So 48, it's an even number. So one thing you could do is you could say it's 2 times 24. 24 is 4 times 6. And so since 4 is 2 times 2 and 6 is 2 times 3, we could say that the prime factorization of 48 is 2 times 2 times 2 times 2, 1, 2, 3, 4 of them, times 3. And that would be our final answer. Same thing with 360. It ends in a 0, so it's something times 10, 36 in this case. 36, one way you could split it up is it's 6 times 5. Although you could also say it's 3 times 12 or 2 times 18. Any of those will get us to the exact same answer. Had you done it this way, you'll want to break down those 6's and say that they're both 2 times 3. And therefore, the prime factorization of 360 is 2 times 2 times 2. Takes care of that one, well, that one, that one, and that one. And we got 2 3's and a 5. And then finally 96, same idea. Few different things. It's divisible by 3, because if you add up 9 plus 6, you get 15, which is divisible by 3. You might also notice that it's even and therefore divisible by 2, which is probably the one most people would do. 2 times something equals 96. That something is 48. 48 is still even, so it's 2 times something, 24 in this case. And actually, didn't we already do 48? We already did 48. We know 48 is all this stuff. So really at this stage, you could just say my answer is 2 times all that stuff. And in case you didn't realize that, I'll keep going. 24 is 4 times 6. So what we get is the prime factorization of 96 is 2, 1, 2, 3, 4, 5 of them, times 3. And now what we want to do is express the following as reduced fractions using our answers from number 1. So 96 divided by 360. Well, 96 is, I just figured out, that's 2 times 2, 3, 4, 5 of these 2's times 3. And then 360, we got up here is 3 2's, 2 3's, and a 5. Oops, 3 2's, 2 3's, and a 5. And what we want to do is multiply that by 6, which is 2 times 3, and 16, which is 2 times 2 times 2 times 2. Can now cancel stuff out. Cancel out those 2's, those 2's, those 2's. Cancel out these 3's, these 3's. Cancel out these 2's, these 2's, and these 2's. So we're able to cancel out everything in the numerator. So we're left with just a 1 up top. And then the denominator, we have a 2 and a 5. So we're left with 10. So our final answer to this, guys, is just 1/10. Down here in this second one, same idea. We'll find the prime factorization. 5's already done. Well, actually, it's not true. We'll take one step before we do that. We'll change this from a division problem into a multiplication problem. Instead of dividing by this number, we can multiply by the reciprocal of that number. And why that's handy is we already have shown above that we can multiply fractions. Let's see, 48 was, I have that up top. It's the product of 4 2's and 1 3. 1, 2, 3, 4, and a 3. 96, got that one right here. 1, 2, 3, 4, 5 2's and a 3. And then 360, have that on the bottom here. It's 2, 2, 2, 3, 3, 5. 2, 2, 2, 3, 3, 5. Now I can take out my red pen and cancel out. There's a 5 here and a 5 here. Awesome. There's a 2 here, 2 here. 2 here, 2 here. 2 here, 2 here. 2 there, 2 there, 3 there, 3 there, 2 there, 2 there. I was able to again get rid of everything in the numerator. So I'm again left with just a 1 up top. And in the denominator, I got 2 times 2 times 3 times 3. 4 times 9, I got 36. All right. Now we're subtracting fractions. To subtract them, we want a common denominator. We already know that 48 is 2 times 2 times 2 times 2 times 3. And 360, we already have over here, is 2 times 2 times 2 times 3 times 3 times 5. So what we need to know is what is the least common denominator. The least common denominator, maybe I'll just say LCD, is, well, let's see, we got 4 2's over here and 3 2's over here. So we'll need at least 4 2's. 1, 2, 3, 4. What about 3's? I got 1 here, but I'll need 2 for this side. So I better tack on 2 3's here and a 5. So in order to make this equal to my least common denominator, I'm missing a 3 and I'm missing a 5. Now I have 2, 2, 2, 2, 3, 3, 5. Exactly what I have over here. In order to make this the least common denominator, I'm just missing a 2. So what I am left with is, on the top here I have 15. On the bottom I have some number, this least common denominator. Maybe we should figure out what that's equal to. Well, note that this thing in green is the same as my least common denominator, except there's one more 2. So this thing in green was 360 times 2 gives me 720. So what I'm left with is 15 720ths minus 2 720ths. So my final answer is 13 720ths. You could check to see if that reduces at all. This does not reduce. The reason I can tell that doesn't reduce is 13 is a prime number, and there's no 13's in the prime factorization of 720, because this is the prime factorization of 720. Just make sure I'm clear about where my final answers are. And then one more, 196 plus 3 48ths. Okay. 96, I have right here, that's 5 2's and a 3. 48, I have over here, it's 4 2's and a 3. So when I'm trying to find my least common denominator, I'll need 5 2's. So I have enough for this side, and 1 3. It's got enough for everything over here and everything over here. In fact, this number right here, this 96, is my least common denominator. So I don't have to do anything to this side. But over here, I'll want to multiply the top by 2 and the bottom by 2 so that I have that least common denominator. That'll leave me with 6 over 96. Get 7 96ths as my final answer. All right, that is the end of this quiz.